So we have now about 100 of us in the room. So let's begin with our Tuesday class. First of all, that if you have difficulty following my English or my course, please watch the YouTube video afterwards, and the link will be found on iLearning. So where did we stop on Thursday? On last Thursday, we covered the first and the second law of mechanics. Of course, it was from Newton. So the first law says the resultant force of a particle is zero, then the particle will remain at rest or will move at a constant velocity. And of course, you know the Chinese of all three laws, but I just want to cover the new words that you might not have encountered or you might not have met in your high school. So the second law is if the resultant force is not zero, the particle will have an acceleration. Acceleration is this one, proportional to the resultant force in the direction of resultant force. So it is essentially F equals to ma. And now we are going to the third law. The third law says something about this one and this one. In English, we call them action and reaction. So what do we know? If we know what the action is like, so we know something about the reaction, right? The forces of action and reaction have this. Please leave this blank. I'll draw a graph here. Or probably I should draw the graph first. Let me draw the figure first. So we have a point here, and we have a force action F. And if we have reaction, if we have an action, if this action is here, what do we know about the reaction? The reaction is then it will be R. Right? So it is reaction. So what do we know about the reaction? So anybody having any idea to type it in the discussion box? Anybody having any idea?
老师，我们没有那个聊天室，好像被关起来了。
We have an action F here, a force F here. Then we have reaction force R here. So we know that they are their size equal or they are unequal in how many newtons? So do these forces equal in size? Are they equal in size? For example, if F is 10 Newton, so is R also 10 Newton or 20 or 5 Newton? So it should be 10 Newton, right? So, and these two have the same size, but in science or in mechanics, we will say, or later on in mathematics, we will say they have the same magnitude. I will highlight it afterwards. So we have a lot of new words here. Please write it down, and I'll give time. I have the So if you have finished copying, please raise your hand. Let me know.
老师，听得到我的声音吗？老师，哎呀，被笑死，老师被隔离是不是
Hello，
老师听得到吗？
听不到。同学，你要不要开个镜头？我这样讲他听得到吗？
Oh, so okay, thanks and thanks for letting me know. I don't know why it does not work in the. Okay, thanks for letting me know. Okay, yeah, sorry, and because I'm still new in. Okay. Wait a minute. I think. Wait a minute. So first of all, let me know. Raise your hand if you have finished copying things. I see your I see. Okay, thank you. How should I change the size of the icons? Let me see. Wait a minute. So and thanks for letting me know about and you are. So it's good to let TA know that TA told me that you have spoken, but I did not hear you. So it's good. It's a good thing. And wait a minute. Why is it like this? And I will sort it out soon. So thanks for letting me know. I will sort it out with TA when I have time. So here for the words that this one means means size. So we still have two words to sort out, and this one and this one. Okay, so in this these two words that I don't think you can find it in the dictionary, because this especially the last one, because it is on only this book use this textbook use this term. So line of action. If we know that this one, because if we have a force G here, that it is not equal to F, although they have the same direction, going this direction, but because they are on different lines, that so they are different. So we specify, or we need to fix, or we need to tell the others the line of action. That means which line does the force is acting. Line of action means this line. Means this line, okay? Line of action means this line. And along a line of action, there are also two possibilities. There remain two possibilities on a line of action. One is to the right hand tops, to the right hand towards the upwards, and towards the left downwards. So in this book, we say these two are called the two senses. Is that okay? So after you copy this figure, that can you raise your hand, please? I need to chat with the TA. That wait a minute. Okay. So so I will. So about the communication problem, that I will sort it out with my TAs maybe after the lecture today. So thanks for letting me know. If you have I think I know why. Wait a minute. My settings. Okay, so and now we go on with after we finish introducing the three laws of motion by Newton, that we go to the units we use in the course, of course, and I think you know some of these words, and mass is this one. Wait a minute, I think I will use right. And then this is force. Speed is this one. Okay, and so in the high school, that force is expressed either in Newton or kilogram force. If we put a kilogram of mass on the floor will have a force like 1 kilogram. Usually at high school, the physics teacher probably tells you to write it like this. But in our course, please do it like this. That's because kilogram itself is only a unit for mass. It is not a unit of force. So please write it as either kilogram force or kilogram weight. I like this one more. I like kilogram force more. Because kilogram weight can only, usually for kilogram weight, it only means downwards, but the kilogram force can mean a force go towards any direction. Okay, so is that okay? And for those who have, for those who can go to the meeting chat. And so for this, for speed and acceleration, we have this kind of symbols, this kind of units. So how should we say it in English? Of course, you can also turn on the microphone if you want to. Any idea? I hear somebody is turning on microphone, but I don't know who. Anybody knows how to, for example, that for this one, how should we say it one word by one word in English? If you can go to the message box, you can type it down. Or if you cannot, you can switch on the microphone and say it.
Miles per second. Is that right? I guess.
It seems I really have a problem with here. So let's go on first, and I will sort out the problem later. Can you see me on the? Can you see my face on the screen? If you can, please raise your hand. So you can't see me on the screen, okay? But you can. Good. No, thank you. And so in here, the speed, the unit of speed, for example, this kind of thing, we say meter per second. And for acceleration, oh, thank you. I will restore this. Okay. The TA can hear one of you have given the answer. Thank you. And why can't we listen to you? That is this. I'll sort it out in the break. I'll sort it out during the break. So for this one, meter per second. This one we call it meter per second squared. Meter per second squared. So for free falling object, free falling is this one. Okay, let me lower all the hands. So I will and free falling is this one. Oh, free falling. Let me write it down. I'll sort out the problem during the break, and sometimes it's me being stupid that is to forget to switch on to have my headphone. It can happen, so I will check it with my TA during the break. So raise your hand if you have finished copying. And after you finish copying, go to see if there are any words that you don't understand. If you can type in the chat box, if you can type in the chat box that please type it down, or when you speak it, the TA will know and they will tell me, because I don't know why I can't hear you. So we know what is, I think we know what is magnitude. We know that is magnitude. And what else? Okay, thank you. And so let me put down all hands. So, and there are two words that you have met them in English class somewhere, but they have different meanings in the engineering. Subjected to, this is subjected to, that the accent is on the second syllable, means this one. And acting on means it's okay. Subjected to means influence. Means influence. And acting on means putting force on. So we say a particle is influenced by gravity, so it can accelerate by g 9.81 meter per second square. And so the magnitude of weight acting on the force put on the particle is equals to F equals to mg. Is that okay? So if you find that, please raise your hand. So if you are find that, or do you have any questions? And if you have any questions, please let me or let the TA know, because I think the TA can listen to you, and I don't know why I can't. And so if you are fine that, let's take a short break, because this is the end of chapter 1, and I will talk to the TA on the communication issues. Okay, so let's take a 10-minute break, and then we'll come back at 2:50.